All right, so I'm going to do the example that we did in a PowerPoint on class, just using our old method of using the notes, because doing it differently seemed to throw a few people off. So let's go and I'll share screen and we'll do it as we used to do it. So you're looking now at my paper. So what I've done is I've taken the homework and I've laid out the problem that I did in the PowerPoint here as if it was written for the homework. So calculate the soil expectation value of 1 acre forest plot, Douglas fir plantation with the following costs and revenues plan. Discount rate 4%. Here I have a planting cost at age 0 of $200, and I have a timber revenue at age 55 of $3,620. So what do I want to do? I'm having a perpetual periodic that I need to do, and I know that that equation, right, is going to be a not one time, because I'm going to do this over and over again, not every year, but every n years forever. So it's this perpetual periodic equation that we have here. And when I'm doing that, I can write my equation down. So let's just do that first. So VO equals A over 1 plus I to the n minus 1. Probably should have started with my timeline. So let's do that. I'm in year 0. I have a negative 200. 55. I have a negative 200 and a 3620. And out here at 110, I have a minus 200 and a 3620, and so on, 165, right? So I have this series that are just going to go on and on and on. I can manage this land in perpetuity here. That's that soil expectation value that I was talking about. I have an A here, an I, and an N. So what I'm thinking about here is, as opposed to applying this and cutting it into 4 parts, or sorry, 2 parts like we would have done before, or 4 parts like you would have in your homework because you have 4 pieces, if I know that when I apply this equation, it looks like this, right? I have a VO, an N, a 2N, a 3N, and on and on and on, and there's this A. And if I know that these equations are harder to apply than, say, the single value equations, maybe I want to just apply that equation once. And in that case, maybe I want my A to be just one value. How would I do that? So I could add these 2 together and have that be the value moving out through time. Or if I wanted the value to be 1 rotation, I could take this and move it out here to the end, right? The negative 200 out here, which would essentially move all of them out, in which case I would have something like negative 200 times 1.04 to the 55 plus 3620. So that could be my A. So I've basically taken the value that was here and moved it out there, so that when I apply this equation, I've got a solution here at 0. I can do it many different ways. A lot of times when we're talking about these systematic things, people want to see the value of one of those systematic loops. If that's my A, there's my I, 4%, and my N of 55. And in this case, the soil expectation value, or this VO, would be VO equals, and here I'll just write my A out, 200 times 1.04 to the 55 plus 3620 over 1.04 to the 55 minus 1. So it may seem silly in me doing it here with just these 2, right? But once you get to where you have quite a few, it may be easier to slide this one and this one out to year 40, combine them all together, because I can add them together once they're in the same year, and then only apply my equation once. In this case, I get a VO equals 247 and per acre. Right, so that is all of those things in it. So that's the gist of the soil expectation value. It's that simple. Don't get caught up in the terminology. And in some cases, when I'm doing a PowerPoint, maybe don't try to take notes. I know I go a little fast. It's because I'm trying to get a lot of stuff in. I only get a little time in front of you people. And so I'm trying to just lay things out there. This is math that we're doing. And so you can also just not take notes, watch, and then you can watch it again because we're going to record everything and everything will be posted if that's easier, right? But this is just the way that we have done things. I could have laid it out separately. I could have had a, in this case, if I look at this and I want to have my VO here, I could have the part that is 3620, and that's just 1.04 to the 55 minus 1, right? That would be this one, and then minus, and there's that 200 over 1.04 to the 55 minus 1 minus 200, right? Because that would be all of these, but not that one. You know, that's going to equal 247. I could do VO equals 3420, which is the 3620 minus the 200. I can combine them there over 1.04 to the 55 minus 1. And then I have to subtract off 200 because that would be all of these, but not that one. I can do that. You know what that's going to equal? 247. So whatever works for you, right? I was just trying to apply it some different ways. So you can think about these in many ways. You just need to capture them all. In yours, it's a little more complicated. So maybe crunching things into a single place first before you apply the more difficult equation would work. So now, just like in our homework, right, with this forest plot here, let's say it was 30 years old. What's the land and timber of that 1 acre plot? And so in this case, it's 30 years old right now at year 0. So that's the age, and this is the year, right? Are there any costs and revenues at age 30? No, there's nothing there. And out at 55, which is 25 years from now, there would be a revenue, 3620, and then all of this stuff would stop, right? I'd have to plant, and I could basically slide that timeline on there, but I don't want to do all that again. I know that the value of that is 247. So I can just put that there. It is perpetual because it has all of this stuff calculated right here. So it's already perpetual. That 247 includes all of the future things in our timeline. So it's as if I put that timeline there. So now I just have the one step. I can just take my VO, which is here, which would be my land and timber value, and this would be my soil expectation value, right? I can take that as just being 3620 plus bare land, which is all future costs and revenues, discounted 1.04 to the 25. So I'm just taking this value and sliding it back there using my single sum present value equation there, right? And if I do that correctly, I should end up with 1451 per acre. That's the land and timber value. I don't need to put all the future things in here because that was the benefit of doing this part first, is that I've eliminated the need to do that, right? 1451. So the fire loss one, if you're thinking about it, right, we talked about different ways you could think about what a fire loss would be. Is it the value of the standing timber that's out there now? The example was 500. Not really. Is it the value of waiting, the trees just waiting to the end of the rotation? So just taking this 3620 back, and no, it's not that either. It's the difference between the two, right? What I had before the fire What did I have before the fire? In this case, I had 1451 per acre. And what do I have after the fire? I don't have 0. I have 247. I have this. I could plant it and do it. So what did the fire do? I had this before. I have this after. I can subtract those, and that becomes then the fire loss that I would use, or 1204 per acre. Okay, so that's a different way of doing it, using just our equations. Do go back and look at the other one as well. There's many ways that you can solve these. And so all we're trying to do is get to the answers, the values that are out there, right? Values are everywhere. We have to be able to account for them. And what I'm trying to get you to do is think about things through time in ways that you can compare different options, or where you can look at how time plays a role in determining the damages that you might have for different activities. So with that, I would go back maybe and watch that PowerPoint and think about it from this perspective and just what it's laying out, and on we go. Thanks, guys.